the subtractor amplifier. By that name, subtractor or differential. It means difference between two different inputs. These two inputs will be E1 and E2. E1 and E2. For us to get a value that will be positive, it must always be that E2 is greater than E1. And if you look down from your manual, you see where the formula is written. E0, which means E output, equals to E2 minus E1. If we are to follow that formula, if E1 is greater than E2, then means we have a negative input value. Is that not? Yeah. So then, I said, looking at the formula, E out, E0 equals to E2 minus E1. But in this experiment, it is always very hard somehow to get to saturation. Because if you keep moving at the same rate, when you input E2, 0.3, E1, 0.2, you move again to 0.3, 0.4, 0.5, 0.6, 0.7, you might not get to saturation. So you make the gap of the input to be a bit wider. So in that, you can have that saturation point. Do you understand what I'm saying? Yes. I've talked about the feedback resistor, which gives the system stability. So do we have to go through the connection process? We should go through it. Now if you look at this, the whole of this, we have resistors. You have 100k resistor, 10k resistor, 100k resistor. So, and if you look at this apparatus or the machine, the operational amplifier, you see that we have different kind of resistors value. So what we are going to use is what we are going to connect. It's IC741. Is an operator. It can take in the positive and the negative. Where you don't need, probably you want to input a positive input now, so you can ground the other hand, and that's why you have those connections. You see where the main input will be given to you, but the other hand where you don't want the inverted output for the summing, you see it is grounded through a 1k resistor. Yes. Now we are going to look at this religiously. In religion, once you are asked to say Allahu Akbar at a point and you didn't say Allahu Akbar, you have failed that procedure. You must take it again. So that is religion, and it is like that in engineering. When you fail procedure, you don't get the right answer. We are having it. It also has its own input and output. It has input and output. The input are where the signal goes into the operational amplifier. It has a positive one and the negative one. Then it has output. All this will be monitored by our meter. The two inputs will be monitored by E2 and E1. While this last one will be monitored by output. This last one is monitoring the output. Now, by the connection, if you look at this, this is the feedback resistor, 100k. Now, this is the link, the 100k. This is 100k. One end goes to the input, and the other hand, one end goes to the input, the other hand goes to the output. Like that. So now to the negative input, that's pin 2. A 10k resistor now go to a variable input. So looking at it this way, this is a 10k resistor, it goes to this input. So now it goes to this input, and this input, this is the positive end of this input, the negative is taken to the ground. You can see the symbol of ground. Now, at the positive input, You have a 10K resistor to a variable voltage supply. So that 10K resistor is this one. Is this one connected to E2. Then the last one, we have an 100K resistor grounded. Now, this is 100K resistor connected to pin 3 and connected to ground. Are we together?
Yes.
Now, the operational amplifier itself, it needs an input for it to function. It needs a 15-volt positive and negative input. So if you look at this supply end, you see that on this we have negative 15 volt and we have positive 15 volt. If you take it up, you see where they have positive input and negative input. This is attached to the negative input. So at this end you have the output, the output meter attached to the output. This is grounded because we want to measure out. Let's turn it on. Now, let us eat. So let's go from E1. Oh, sorry. On. Like I was saying the other time, I've made, don't record yet, I've made E1 to be greater than E2 and the result will be a negative output. I don't want you to see that. Is 0.24 and E2. Please let's have a table of 4 columns. This first one will be serial number 1 to 5. The first one will be then E naught, E output. If you like, you can create a 5th column showing the difference between E2 and E1. If you like, you can create it. Something 4 point something. You have 0.43 something. As long as get us a calculator. 0.772 minus 0.341. Someone to record that down.
That is 0.431.
The answer is 0.431. This is the imputed voltage after the difference between the two. So it is this inputted voltage the amplifier will amplify. But because of the gain of the amplifier we call 10. How do we get 10? The input resistor divided by the feedback resistor. Yeah. Feedback divided by the input resistor, which means 100 divided by 10 will give us 10. So it is that you now multiply by the value you are inputting to give us the output. So when you multiply 10 by 0.431, you will be getting 4.19 something. It's not as exactly as they calculated, and that is due to some plus or minus different unit, like 2 decimal places, 3 decimal places. If you have written for 2 decimal, let all be that. Don't record 0.3 in one column, another 0.2 in one column, another 0.1 in another column. It will not make the result to be regular. It has to be uniform for a better result. So,